Now we're going to solve radical equations. Got steps here that we need to follow. First thing is isolate the radical. If an equation has more than one radical, choose one of the radicals to isolate. Step 2, raise each side of the equation to a power equal to the index of the radical. So in number 9, the radical, that's a square root, the index right in there is understood to be a 2. So I would raise both sides to the second power. And this one, both sides to the second power. If it were cube root, then I raise both sides to the third power. Now in step 3, solve the resulting equation. If the equation still has a radical, we have to repeat steps 1 and 2. Step 4, check the potential solutions in the original equation and write the solution set. In solving radical equations, extraneous solutions potentially arise when both sides of the equation are raised to an even power. Extraneous means additional solutions that don't work. Therefore, an equation with an odd indexed roots will not have extraneous solutions. However, it's still recommended that all potential solutions be checked. So solving the following equations. Step 1 said to isolate the radical. So I'm going to subtract 3 from both sides. To get rid of square root, you square both sides. This side's nice. This side, remember to FOIL because it's that binomial times itself. So that would be x squared minus 6x plus 9. If you need to write that as x minus 3 times x minus 3 and FOIL it, then do so. You do what you need to do in order to get the problem correct. Now, I'll move those terms to this side because I like my a value to stay a positive 1 or positive. So I'm going to subtract x, add 1. Stop me. I need you to factor that, then start me up again. So if I factor this, looks like I need a 2 and a 5, and they both need to be negative. So hopefully you ended up with that. Separate those factors, set them equal to 0. So I've got x equals 2, x equals 5. Now we need to check, make sure. So let me see if I can get this over here so that won't be. So let me store 2 in. Type in left hand side. Right hand side's x, so if this side comes out to be 2, then we're okay. Well, it doesn't. That's an extraneous solution. Let's try 5. Second enter, second enter. So that's my left hand side. Let's see if this comes out to be 5. That does work. 5 equals 5. So this is my solution. Don't erase, just put a little x on it. That'll be fine. Now in this one, I've got a radical here and a radical here. I can't really isolate the radical. I've got 2 of them. So this is one of those situations where we get down to step 3 and we have another radical. But since I've got one radical over here, let's go ahead and square both sides. So that's 1 minus 2x equals, now this means this. Two times 2 would give me 4. The outside is a 2, square root of 1 minus x. The inside's a 2, square root of 1 minus x. So that would give me a 4 square root 1 minus x. Plus that thing squared, which is just itself. So clean up what you can. So it'll give me a 5 minus x plus 4 square root of 1 minus x. Now, this is where in step 3 I still have a radical, so now I need to separate it, get this term by itself, so I'm going to move both of these to the other side. So if I move that, that would give me a negative 4. Move that, I would add it, so it would be a negative x equals 4 square root of 1 minus x. Alright, now I square it again. Keep doing this until I get rid of the radicals. So squaring this side, again, if you need, go and write it down. So negative 4 times negative 4 gives me 16. Outside would be a positive 4x, inside's a positive 4x. Last times last would be a plus x squared. Okay, now this one, I've got two factors here. So the 4 has to be squared and that has to be squared. And you have to keep, here I am talking, not doing. 4 squared is 16. That squared is just 1 minus x. Notice I left it in parentheses because the 4 is going to be multiplying that. So you need to keep that. So I've got 16 plus 8x plus x squared is equal to 16 minus 16x. So I'm going to get everything over to the left-hand side this time and put it in descending order. So I've got x squared, add 16x to both sides, subtract 16. So I've got a nice little binomial now. Let me factor out my x. So I can have x equals 0 or x plus 24 equals 0 or x equals negative 24. Now let's see. If I put 0 in, let's see if we can do it in our head. Got to go back to the original. I'd end up with square root of 1 or 1. Put 0 here. I would have 2 plus 1, which would be 3. So that one does not work. So let's see if negative 24 does. So negative 24, storing for x. Move it a little bit so I can see the original. Square root 1 minus 2x. Get that out, and that's the left-hand side. Right-hand side, seven equals 7. So that is my solution. That one is a little bit longer because we had to go through the process of squaring both sides twice. But it still came out pretty good. I think you'll like the last two. This technically is cube root of x squared. But in order for me to get rid of that exponent, because I need to solve for x, I multiply by the reciprocal. The exponent, that is. Remember, I got to do the same thing to both sides. So I'm going to take both sides up to the 3 halves, and I end up with just x here. 4 to the 3 halves. The denominator tells you the root, so I'm taking actually the square root of 4, which is 2, and then raise it to the 3rd power. I should end up with 8. So if I go 4 raised to the 3 divided by 2, so let me store that, and I'm going to do x raised to the 2 divided by 3. And it equals my 4. These were nice. Those are so cool. This one is to the 1/5. Well, take both sides exponent-wise up to the 5/1 or to the 5th. That gets rid of this. This is just x plus 1. Negative 3 to the 5th. I think it's negative 243. See if it is. Subtract 1 from both sides, so x needs to be a negative 244. Oh, I didn't circle and check that. So let me store negative 244. 244, storing for x. Parentheses, x plus 1 raised to the 1 divided by 5. And if we come up with negative 3, yay, that's my answer. So 9, 11, and 12 were fairly fast. 10 is a little bit longer because, like I said, we had to do the squaring both sides in order to finally get rid of that radical. So practice these